Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 527. Please turn to page 527. Today is our lesson number 37. Problem number 6 is what we're going to do there. Problem number 6 deals with the notion of proportionality. Two variables being directly proportional. Let's first understand what it means for two variables to be directly proportional. For example, if we have a variable x here and a variable y, and let's say we have values here 1, 2, 3, 4, let's keep it very simple, and we have 3, 6, 9 and 12. What do we observe here? What do we notice here? We notice that every time x goes up, so does y. Every time x goes up, y goes up as well. And every time x goes down, for example, if x was 4, if x goes from 4 to 3, y goes from 12 to 9. If x goes from 3 to 1, y goes from 9 to 3. In other words, they move in the same direction. When x goes up, y goes up. And when x goes down, y goes down. When we have a situation like this, we say that x and y are directly proportional. X is directly proportional to y. And what else? Other thing that we notice here is that not only that y goes up every time x goes up, but we also notice that it goes up by the same increment. It always goes up by 3. 3 to 6, 3 to 9, 9 to 12. It always goes up by the same increment. That constant increment by which y goes up each time, it is called proportionality constant. Here, the proportionality constant, which we usually represent with letter K, is 3. And this equation would simply be y equals 3 times x. This is how we would write it. Y equals 3 times x. When x is 1, y is 3 times 1, which is 3. When x is 3, y is 3 times 3, which is 9. When x is 4, y is 3 times 4, which is 12. This is how it turns out. And this is our proportionality constant. 3 is our proportionality constant. Now this is a scenario where x and y are directly proportional, which means when x goes up, y goes up. When x goes down, y goes down. They move in the same directions. They both either go up together or they both go down together. They move in the same direction. If you have a situation something like this, where y equals to 1 over x here, what's going to happen here? What's going to happen here? Here, when x is 1, y is 1. But when x becomes 2, y becomes half. Y drops. When x is 10, y goes even lower. It becomes 1/10. So here, when x goes up, y is going down. When x goes up, y goes down. And here we say x and y are inversely proportional. And this is how we write it. X and y are inversely proportional. And you will see that x and y are inversely proportional. This is how we write it. And in this scenario, in this example, the proportionality constant happens to be 1. That's it. So that's what this problem is dealing with. We are told that x is inversely proportional to y. So this is our equation that we start out with. This equation right here. Right here. X is inversely proportional to y. Let's erase this part from the past. So x is inversely proportional to y, which simply means that that x must equal some variable k times 1 over y. K times 1 over y. Or rather, it doesn't really matter, it's the same exact thing. It's just the value of the k would be different here if you write which form you write here, but k is constant. And then we are told, the question simply is, which of the following is directly proportional to x squared? So somehow we have, the reason it doesn't matter is because we can multiply both sides by, if you were to multiply both sides by x over y, if I multiply this side by x over y and this side by x over y, this y will drop out and here we'll end up with x equals k times this x will drop out, 1 over y. You see, it's the same exact thing. It doesn't really matter. It's just a switch where you put x and y, it makes no difference because you're cross multiplying. We are interested in, question is, which of the following is directly proportional to 1 over x squared? 1 over x squared. So first of all, we got to make this into x squared. So if you square this side, we'll have to square that side. K times 1 over y squared, which is going to give us k squared times 1 over y squared. Now k squared is still a constant. It's still a constant. If the constant was 3 before, now it becomes 9, but it's still a constant. So we can give it a new name. We can call it k2. It doesn't really matter. It's just another constant. It's just another constant. So we're just going to call it, instead of saying k squared, it will be silly. Let's call it this one k1 and this one k2. So this tells us that x squared equals some constant times 1 over y squared. We are interested in 1 over x squared. We are interested in 1 over x squared. So we have to take the reciprocal of the whole thing. So if you take 1 over x squared here, this will become 1 over k squared, 1 over k2, and this will become y squared. And this is again some constant number. This is some constant number. Let's continue up here. So what we end up here, from here we're going to go up here. So from here we have 1 over x squared equals some constant. 1 over k2 is just some other constant, k3, equals y squared. And since this is a constant, now we can see that 1 over x squared, is directly proportional to y squared. The question was, 1 over x squared is directly proportional to what? And the answer we just found out, that 1 over x squared is directly proportional to y squared. And that's your answer, E. Now listen, I do realize that this is not something that everybody is going to understand. I realize that not all the students are going to understand it. So if you're not very familiar with it, if you're not very comfortable with it, if you're not acquainted yourself with the notion of two variables being directly proportional or two variables being inversely proportional, of course you will have trouble understanding this thing. And my constraint is that, my limitation is that we are solving a SAT math problem. I could hardly turn this into a 1-hour lecture to make you understand the basic concepts that lies behind it. We obviously cannot do that. So we do what we can. I did what we could do in the limited amount of time that we have, because we got to keep on moving. And if you still have trouble understanding it, then you're going to have to skip it in the real exam. If something like this appears in the real exam, you're going to have to skip it, obviously. Do you understand? I'm sorry to have to say that. Let's go to the next one. Number 7. But that's it. As far as this problem is concerned, we are done. 1 over x squared is directly proportional to y squared. Question number 7. Question number 7 says, point A is a vertex. What's a vertex? A vertex is a very fancy way of saying a corner of a picture. Vertex. Well, we're going to draw our picture just now. Let's find out what kind of picture it is. Point A is a vertex of an 8-sided polygon. Well, there you go. It's an 8-sided polygon. So let's draw it here. 1, 2, 3. There's 3 over there. 1, 2, 3. 3 down here. And then here's your 4th. And here's your... So this is an 8-sided polygon. It has 8 sides to it, and these are called, this is the vertex, this is the vertex, this is the vertex, this is the vertex, this is another vertex, this is another vertex, and this is another vertex. So as I said, vertex is a very fancy way of saying a corner of a picture. Vertex. Here we have 1, 2, 3, 4, 5, 6, 7 vertex. No, we do not have 7 vertex. We have 7 vertices. That's the plural. Plural of vertex is vertices. Anyway, enough of the talk. Point A is a vertex of an 8-sided polygon. So we're just going to pick any point here and let's call it A. Let's call this one A. And then what happens? The polygon has 8 equal sides and 8 angles of equal measure. Oh, good for it. When all the possible diagonals are drawn from point A, how many triangles are formed? Oh, for crying out loud. This is too simple. How many triangles are formed? We just draw the diagonals, that's all. Let's call it here A, B, C, D, E, F. A, B, C, D, E, F. What the hell is the matter with me? And G and H. Obviously, A to B is not going to be diagonal because A to B actually is the side of the polygon itself. So the first diagonal we're going to find is A to C. That's called a diagonal. The next diagonal we're going to find is A to D. Another diagonal we're going to find is A to E. And then A to F. And then A to G. And A to H does not count because A to H actually is the side of the diagonal itself. Similarly, A to B does not count because A to B is the side of the diagonal itself. It's not, I don't mean to say the side of the diagonal, I mean to say A to B is the side of the polygon itself. A to H is one of the side of the polygon itself. It's not a diagonal. Diagonal simply means you join two corners, but not these two obviously. So that's it, we're done. They just want to know how many triangles are formed, for crying out loud. Just count them, that's all. 1, 2, 3, 4, 5, 6. 6 triangles are formed, that's it. The answer is 6. Okay, and the answer is 6. I do not know why this one was classified as a hard question. Number 8, shall we? Number 8. In question number 8, we're given an equation. It goes something like this. It goes something like this. X minus 8 times x minus k. Let's do it on the top. There is no reason why we should save this picture. X minus 8 times x minus k equals x squared minus 5kx plus m. Now listen, before we do actually this problem here, I just want to make sure that you understand the basic concept that lies behind it. For example, if someone tells you that 5x squared plus 3x minus 9 equals ax squared plus bx plus c, will you be able to tell the value of the coefficient a, b and c? A, b and c are the coefficient. A is the coefficient of x squared, b is the coefficient of x, and c actually is a constant itself. It's not a coefficient of anything. Technically actually it is a constant. Technically it is c actually, technically speaking, theoretically speaking, c is also a coefficient of something. You know what it is coefficient of? Watch what happens. I'm digressing here big time. We'll learn this word in a second. You see here we have a raised to x, second power. A, x squared. Then we have b, x, which is same as b raised to the first power. And finally the c that you see there, technically speaking it is c times x raised to 0. Any number raised to 0 equals 1. Therefore, it is just c times x raised to 0, which is same as c raised to c times 1. And because it is c times 1, we don't actually have to write 1. So here technically it is c times x raised to 0, but x raised to 0 is 1, and you don't see it. But it is there. It is there. Anyway, so will you be able to tell me the values of a, b, and c? Well, it's very simple. It is very simple. All we have to do is match the thing here. Here we have x squared, here we have x squared, which means the coefficient that you see here must equal the coefficient that we see here. A must equal 5. Similarly, b must equal 3, because b is the coefficient of x. And finally, the c that we see here, c must equal negative 9. C must equal negative 9. B must equal positive 3. And A must equal positive 5. Of course, if you understand this notion, that's exactly what we're going to do here. Nothing different. Nothing different, even though it is classified as a level 5 question, but there is no difference here. It is supposed to be the hardest question. There are, in this particular section, they give you 18 problems. They give you 18 problems, and all the questions are arranged in the order of difficulty. As I always remind you when we get to this particular section, just because all the questions are arranged in the order of difficulty Here, it does not mean that the first 6 are easy, the next 6 are medium, and last 6 are hard, because there are 18 of them. It doesn't mean that. All the questions have to be of the same type before that would apply. And they are not here. They are not of the same type. We have 8 multiple choice questions, and we have 9 through 18. We have 10 grading questions. So 1, 2, 3, 4, 5, 6, 7, and 8. These are, even though it's only number 8, it's the most difficult multiple choice question in the section. And then, starting with number 9, a new scale begins. So question number 9, because there are 10 of them, because there are 10 grading questions, question number 9 is the first one, which means on a scale of 1 to 9, on a scale of 1 to 10, question number 9 is level 1. On a scale of 1 to 10 is 1. Question number 9 is going to be very simple, very straightforward. Question number 8 is supposed to be a level 5 question. We'll find out. Let's finish it up. So here we get x times x, which is x squared, and then we get x times negative k, so we get negative kx. Here we get negative 8 times x, so we get negative 8x. And finally we get negative 8 times negative k, we get positive 8k. And that has to equal x squared minus 5kx plus m. Watch what happens. Just like before, we're just going to match the coefficient. Here we have, well actually, this one has a coefficient of 1 and this one has a coefficient of 1, so they are obviously, we are not interested in x squared. So here we have a coefficient of negative, oh actually, we are not done yet, this is too early. It's too early for us to talk. We have to combine this part. This is kx and this is 8x. Let's combine them. Take out x and you get negative x and you will get k plus 8. X squared. I was too early, I was too much of a hurry to, I thought we were done, we were not. We have to combine the kx and 8x because they both have x's in there. Take out the x common and you'll end up with k plus 8. And here we have 8k equals x squared minus 5kx plus m. Now as you can see, we have a negative here in front of x and we have a negative here, so they are both negative, so that part you don't have to worry about. So here, k plus 8 that you see must equal this part, 5k. K plus 8 must equal 5k. It must equal 5k. And similarly, this 8 must equal m. Oh sorry, 8k. 8k here equals m. Because that's the constant. That's the constant here, that's the constant there, so this 8k must equal m. That's it, we are done. We solve this equation for k, and once we have the value of the k, put it in there, find the value of m. So let's solve it. Subtract k from both sides, and you find that 4k equals 8, and therefore k equals 2. Once we have the value of the k, put it in there, and we'll find that m equals 8 times 2, or 16. That's it, that's our answer. 16 is the answer. Answer is letter B. The answer is B, 16. That's it, we are done with these 3 questions. As I said before, as I reminded you before, these are supposed to be the toughest question and the multiple choice portion of the exam. There are 8 of them and these last 3 are difficult. Tomorrow we'll do the grading questions, okay? Again, in the grading questions, there are 10 of them. Why don't we take a look at it right now just so you know what's going on. Turn the page and you will see on page number 528 there are 2 gradients. Those are easy gradients. On the following page you will see 4 more gradients which are on page 529, which are medium gradients. They're going to be all level 2 and level 3 questions. As you turn the page, the last 4 questions on page 530, these are the most difficult questions in the entire exam. These are level 4 and 5 gradient questions. And typically, the level 4 and 5 gradient questions are even more difficult than the level 4 and 5 multiple choice questions for some strange reason. Do you understand? Anyway, we'll get to them eventually. I'll see you tomorrow, okay? Bye now.